In last lecture, we discussed about edge runner mill and end runner mill, which is the last point of the size reduction chapter. So in this lecture, we will start a new topic, that is size separation. In normal, the process of size reduction is followed by size separation of the powdered material. During the process of size reduction, it is not possible to obtain the particles of uniform size. Hence, a special technique is used to separate particles of desired size, which is known as the process of size separation. Then, what is the definition of size separation? The size separation is a unit operation that involves the separation of a mixture of various size particles into two or more portions by means of screening surfaces. The size separation is also known as a sieving, sifting, screening or classifying. Means what is the size separation? Size separation म्हणजे काय तर सिंपल sieve मधून एखादं मटेरियल पास करणं. Okay, which is called as a size separation. This technique is based on physical differences between the particles such as size, shape and density. Then next point is objectives and applications of size separation. In that this size separation is used to determine particle size of the production of tablets and capsules, also used to improve mixing of powders, also to improve the solubility and stability of particles during production. Here it is used to optimize feed rate, agitation, screening during production. Also it is used for quality control of raw materials and also used for in the production of tablets, capsules, suspension, emulsion, ophthalmic preparations, ointments, creams, etc. Then next point is here size separation. A special technique is used to separate particles of specified size, which is known as the process of size separation. Here the official standards for powders are given. In that the Indian Pharmacopoeia had laid down the standards for powders for pharmaceutical purposes. The Indian Pharmacopoeia specifies 5 grades of powder, which are as follows. 5 grades, which 5 grades? Such as coarse powder, second is moderately coarse powder, third is moderately fine powder, fourth one is the fine powder and fifth is the very fine powder. Means हे असे ग्रेड आहेत की त्या ग्रेडमधून म्हणजे वेरियस टाइप्स ऑफ ग्रेड आहेत. ह्या ग्रेड हे ग्रेड आहेत आणि एक प्रकारचे सीव नंबर्स असतात, लाईक सच ॲज 10 number sieve, 22 number sieve, 44 number sieve, 85 number and 120. Here like this, here this coarse powder grade is coarse powder, then sieve through which all particles must pass, that is sieve number 10. Here sieve through which not more than 40% of the particles pass. Means here material is passed from 10 number sieve and the not more than 44% means 44% पेक्षा जास्त मोठी साइज असलेले पार्टिकल should not passed from that sieve. Here moderately coarse powder grade, then the sieve number is 22 and the sieve through which not more than 40% of the particles pass, that is 60. Also moderately fine, it is 44 and here 85. Then fine powder possesses a 85 number of sieve and it is not specified. Also very fine powder, the sieve number is 120 and it is also not a specified number. Okay, also it possesses a nominal mesh aperture size, also it possesses a nominal mesh aperture size as well as sieve through which 40% of particles pass here. Then we discuss these grades one by one here. First is the coarse powder, a powder of which all the particles pass through a sieve with nominal mesh aperture of 1.70 nanometer, that is sieve number is 10 and not more than 40% through a sieve with nominal mesh aperture is 355 micrometer, that is sieve number is 44. Here the coarse powder means मटेरियल 10 नंबरच्या सिव मधून पास झालं पाहिजे. ओके, ॲट द मेश अपर्चर इज 1.70 mm but not more than 40%. It should not pass into not more than 40% sieve with the nominal mesh aperture is 355 micrometer, that is sieve number is 44. Then next is the moderately coarse powder, in that a powder of which all the particles pass through a sieve with nominal mesh aperture of 710 nanometer, 710 nanometer, that is sieve number is 22 here, and not more than 40% through a sieve with nominal mesh aperture, it is 250. Here this is 250 nanometer, not a nanometer, it is 250 micrometer. Okay, it is 250 micrometer, that is sieve number is 60, is called as a moderately coarse powder. Then next is the moderately fine powder. Here, if all the particles of a powder pass through a sieve with nominal mesh aperture of 355 micrometer, that is sieve number is 44. Okay, and not more than 40% through a sieve with nominal mesh aperture of 180 micrometer, that is sieve number is 85. It falls in this group. Then next is the fine powder. Here, in case all the particles pass through a sieve with a nominal mesh aperture of 180 micrometer and the sieve number is 85 number of sieve, it is called as a fine powder. Means those particles pass through the 85 number sieve, which gives the proper fine powder. Okay, then very fine powder. If we want very fine powder, then the particle must pass through 125 micrometer size of nominal mesh aperture, that is sieve number 120. It is said to be very fine powder. जेव्हा एखादं मटेरियल 125 मायक्रोमीटर म्हणजे 120 सिव नंबर मधून पास होईल, त्यावेळेसच ते जी काही पावडर असेल आफ्टर साइज सेपरेशन, इट इज कॉल्ड ॲज अ व्हेरी फाईन पावडर. देन फॉर द size reduction we use the equipment mills. Okay, also mortar and pestle, various types of mills for the size reduction purpose. These equipments gives a proper size reduction, but in the unit operation of size separation, we use the equipment. What is the name of that equipment? It is a sieve. Okay, sieves are most commonly used for the size separation. Sieves for pharmacopoeial testing are constructed from wire cloth, wire square meshes, woven from wires of brass, bronze, stainless steel, or any other suitable material. The wire should be uniform circular cross section and should not be coated or plated. There should not be any reaction between the material of the sieve and the substance which is being sifted from it. It means that sieve कशापासून बनवली जाईल, तर sieve एखाद्या वायर क्लॉथ पासून किंवा एखादं वूवन वायर असेल. वूवन वायर कशाची असेल तर एकतर ब्रास, ब्रॉन्झ, स्टेनलेस स्टील किंवा एनी अदर सुटेबल मटेरियल पासून प्रिपेअर केली जाईल. द sieve should not be coated or plated because if when we separate the material from the sieve, in that case the material, okay, the material which we want to separate and the substance, okay, मटेरियल म्हणजे काय, तर आपण ज्या मटेरियलपासून सिव प्रिपेअर केले त्या मटेरियलची आणि जे काही मटेरियल आपल्याला त्या सिवमधून पास करायचं आहे त्या दोन्हीची रिॲक्शन झाली नाही पाहिजे. ओके, सो सिव शुड नॉट कोटेड ऑर प्लेटेड अँड देअर must be no reaction between the material of the sieve and the substance to be sieved. Okay, then next point is the here sieves, this is the sieve diagram. Then next is the types of sieves. Here there are 4 types of sieves are most commonly used in the pharmaceutical processing, such as woven wire sieves. Second is the bolting cloth sieves. Third is the closely spaced bars or screens, and fourth one is the punched plates. Here first one is the woven wire mesh sieves. In that, these sieves are general purposes sieves and widely used in the pharmacy practice. The types of woven wire sieves are two types. First one is the plain wave and second is the twilled wave. Here for fine sieving, metal wire woven sieves are most commonly used. For example, hand sieves. Okay, there are these woven wire sieves are most commonly included in the roller mill, ball mill, etc. during milling. Okay, and these woven wire mesh sieves are having a nominal mesh aperture ranging from 20 micrometer to 3.55 millimeters, with the diameters ranging from 100 to 450 millimeters. Okay, this is all about the woven wire mesh sieves. Here two types of sieves here mentioned here. This is a plain woven wire mesh and it is a twilled woven wire mesh. Next point is the bolting cloth sieves. This is the type of sieve. This is a second type of sieve, that is bolting cloth sieves. In that, these bolting cloth sieves are made up from the nylon, silk and cotton. Okay, this is looks like this. Okay, nylon and cotton bolting cloth sieves. Okay, these nylon cloths are generally designed by their micrometer opening and available in different grades. These are used for the separation of fine powders. Okay, this type of cloths, these bolting cloth sieves are used for the separation of very fine powders. Also, this type of sieves are used in the hammer screen. What is the hammer screen? Hammer screen, it is an equipment which is an electrically vibrated screen, electrical vibrated material screen for sizing moderately small particles or materials. Okay, then next point is next type is bar screens. This bar screens, it is a third type of sieve. This looks like this, means bar screen. Okay, this sieve possesses a bar like structure. The bar screens are generally used in handling large and heavy pieces of material because this consists of a bars, so it is mainly suitable for heavy pieces of the material. The bars are fixed in parallel position and held by crossbars and spares. Okay, then next point is the perforated plate sieves. This is the fourth type of sieve. Perforated plate or also called as a punched plates. These screens are made up from a metal sheet with the perforated holes. Here this looks like a perforated holes. These plates possesses a nominal mesh aperture ranging from 1 millimeter to 125 millimeters. The diameters of the sieve range from 200 to 450 millimeters. This is a perforated plate sieves. Then here also the diagram of perforated plate sieves. It is like this. It possesses a circular aperture or square aperture. Okay. Then this perforated plate, these perforated holes possesses a round, oval, square or rectangular shapes, and also this type of sieves or screens are used in the hammer mill. Okay, it is used in the hammer mill. This perforated plate possesses a round holes. These round holes mainly used for the fibrous materials. Okay, these are mainly used for fibrous material. Also, it possesses a slots. Okay, it possesses a slots like holes. These are used for amorphous and crystalline materials. Also, it possesses a cross slots. These are also used for the amorphous materials and slurries with the coarse particles. Then next point is, this is all about the types of sieves. What are types? First is the oven wire sieves, second is the bolting cloth sieves, third is the closely spaced bars or bar screens, and fourth one is the punched plates or perforated screens. Then next point is the standards for sieves. This is the standards of sieves, dimensions and notification. It is according to British Pharmacopoeia. It is required that wire mesh sieves shall be made from wire of uniform circular cross section, and for each sieve the following particulars are standards. Here these standards are also called as test sieves, means it is a test or specifications for sieves, because the sieves used for the pharmacopoeial testing must match with the following specification. It possesses four types of specifications, such as first one is the number of sieve, second is the here nominal size aperture, third one is the nominal diameter of the wire, fourth one is the approximate screening area, and fifth one is the aperture tolerance average. Here this first one is the number of sieve. In that the sieve number indicates the number of meshes per linear length of 25.4 mm, that is 1 inch, okay, in each direction or parallel to the wires, means the number of sieve. Here the sieve number indicates the number of meshes per linear length of 25.4 millimeters. Okay, this is the first specification for the sieve. Then next is the nominal size aperture, also called as a hole. Here this is a sieve. Okay, sieve possesses a possesses a square like structure. Okay, here one bar and here the second bar is present. In that nominal size of aperture, it indicates the distance between two adjacent wires. Here these wires are present. Okay, here two adjacent wire म्हणजे एकमेकांच्या शेजारचे. Okay, two adjacent wires. Here it represent the side of square aperture. It represent the side of square aperture. In Indian Pharmacopoeia, the Indian Pharmacopoeia gives the nominal mesh aperture size for majority of sieves in millimeter and in micrometer. Okay, the length of in between this square aperture, okay, that is measured by millimeter or micrometer. Then next is the nominal diameter of wire. In that the wire mesh sieves are made from wire having the specified diameter in order to give a suitable aperture size and sufficient strength to avoid distortion of the sieve. In that this diameter and the number of meshes from the basic standards for the sieve, the wire diameter has been selected to give a suitable aperture size, but also to have sufficient strength to avoid distortion. It means that this nominal diameter of the wire indicates the डायमीटर, प्रॉपर डायमीटर असलं पाहिजे, प्रॉपर सुटेबल एक ॲपर्चर साईज असली पाहिजे टू अवॉइड द डिस्टोर्शन, ओके, ड्युरिंग द साईज सेपरेशन. देन नेक्स्ट इज द approximate screening area. Here this standard expresses the area of the meshes as a percentage of the total area of the sieve. Here it governed by the size of wire used for any particular sieve number and is kept within the range 35 to 40%, and this gives suitable strength to the sieve but leaves adequate area of meshes sieves, since these are obviously the useful area of the sieves. It means that this standard expresses the area of the mesh as percentage of the total area of the sieve. It depends on the size of the wire used for any particular sieve, and generally the sieving area is kept which range 35 to 40% in order to give a suitable strength for the sieve. Okay, Then next is the aperture tolerance average, in that some variation in the aperture size is unavoidable, and this variation expresses a percentage is known as a aperture tolerance average. Here the term tolerance is used in engineering practice to mean the limits within which a particular quantity or dimension can be allowed to vary and still be acceptable for the purpose for which it is required. It means that a limit given by pharmacopoeia within which a particular dimension or average aperture size can be allowed to vary and still be acceptable for the purpose for which it is used. Fine meshes cannot be woven with the same accuracy as coarse meshes, hence the aperture tolerance average is lower for coarse sieves than the fine sieves. This is all about the specifications of sieves, dimensions and notations. This point is very important for examination purpose. For the objective questions, it is asked in objective questions or MCQs questions. Then next point is here. Next point is modes of motion in size separation. In size reduction chapter, we discussed the modes of size reduction such as cutting, compression, then impact and attrition. These four types of modes used in the these types of principles or modes used in the size reduction purpose. Also in size separation chapter, there is three types of modes such as agitation, brush and sieve, and third one is the centrifugal force. Here the screening is method of separating particles according to size alone. The basic technique involved is passing the particles through a series of sieves of uniform size. Okay, in this the particles drop through the openings due to gravity, and the coarse particles can drop easily through large openings, but it is difficult to screen the fine powders. So this process can be inducing some motion or movement to the particles. So size separation is basically by three methods. Here three types of modes such as agitation, brushing and centrifugal force. We discuss these three methods one by one. Okay, first is the agitation method, in that the sieves may be agitated in a number of different ways. Okay, in a number of different ways, such as first one is the oscillation, second one is the vibration and third one is the gyration. Okay, so first one is the oscillation. Oscillation means move back or forth. Oscillation, here the working it is looks like a swing, means आपण झोका खेळतोय, झोका कसा मूव होतो, एक तर फ्रंट आणि बॅक मूव होतो. ओके, like this. Here the sieve is mounted in a frame that oscillates back and forth, that is reciprocal motion. Here सिव काय केली जाते, एक अशा प्रकारे टाय केली जाते की ती मूव होईल फ्रॉम फ्रंट टू बॅक. ओके, मूव होईल आणि मूव झाल्यामुळे काय होईल, तिथं प्रॉपर साईज सेपरेशन होईल. मीन्स आपण मॅन्युअली पण काय करतोय, घरी एखादी सिव असेल त्याच्यामधून एखादं मटेरियल पास करायचं असेल, एखादी पावडर असेल. ओके, तर ती पावडर पास करत असताना आपण ती जी काही सिव आहे ती मूव करतोय फ्रॉम वन प्लेस टू अनदर प्लेस. देन वी गिव्ह द प्रॉपर साईज सेपरेशन. ओके, म्हणजे जे काही पार्टिकल्स आपल्याला डिस्कार्ड करायचे असतील ते काय होतील, वरच्या साईडला येतील सिवच्या, आणि जी काही फाईन पावडर आपल्याला पाहिजे असेल ती काय होईल, त्या सिवमधून पास होईल आणि प्रॉपर साईज सेपरेशन होईल. लाईक दॅट हिअर इन ऑसिलेशन टेक्निक द सिव इज माउंटेड इन अ फ्रेम. ओके, इन दॅट in such a way that it moves from back to front. Okay, that is reciprocal motion, and it is very simple method, but the disadvantage is that the material may be rolled on the surface of the sieve. Okay, डिसएडव्हान्टेज काय तर फक्त मटेरियल जर आपण ऑसिलेशन मोशनमध्ये सीव काय केली जाईल, एक प्रकारे टाय केली जाईल आणि फक्त आपण मूव्ह करणार आहे ती सीव. मग मूव्ह होत असताना काय होतंय, डिसएडव्हान्टेज काय तर इथं फक्त मटेरियल सीवच्या सरफेसवरती फक्त रोल होते, ते पासच होत नाही सीवमधून. हा याचा ड्रॉबॅक आहे. ओके, देन नेक्स्ट इज द second method is the vibration method. Here in vibration method the sieve is vibrated at high speed. Okay, the sieve is vibrated at high speed by means of a eccentric device. What is meant by eccentric device? A weird type of device, means this device it is either electrically or mechanically worked. In this vibration technique, the rapid vibration is occurred to the particle that helps the particle to pass through the sieve. Here the electrically vibrated screens are particularly useful in the chemical industry. Means एक अशा प्रकारे सीव्स इथं या डायग्राममध्ये दिसते की सीव काय केले जाईल, 1 by 1 एकावरती प्लेस केल्या जातील. ओके, एकदा सेट केल्यानंतर इथं वरती मटेरियल लोड केलं जाईल. ओके, देन आपण हे स्टार्ट करणार आहेत. हे जे काही इक्विपमेंट आहे ते स्टार्ट केल्यानंतर हे जे काही सीव्ज आहेत, ह्या सीव काय होतील, व्हायब्रेटिंग मोशनमध्ये येतील, व्हायब्रेट होतील. इट इज vibrated electrically. Okay, and electrically vibrated these screens or sieves are particularly gives a proper size separation, and it is useful in the chemical industry for the separation of the chemicals. Okay, also this type of operation used in the hammer screen. Also this type of operation for handling purpose it is light. Okay, it is very easy, and also it is used for the light material, fine material, also dry materials. Okay, and इथं काय होतंय तर फक्त काय करायचं, आपल्याला एक प्रकारची सीव आहे, त्या सीवला फक्त व्हायब्रेशन प्रोड्यूस करायचे. ती सीव व्हायब्रेट करायची, आणि व्हायब्रेट केल्यामुळं काय होतंय, त्या सीवमधून मटेरियल काय होईल, पास होईल आणि प्रॉपर साईज सेपरेशन होईल. The next point is the gyration. In the gyration method, a system is made so that sieve is on rubber mounting and connected to an eccentric flywheel. Okay, to an eccentric flywheel. इथं पण एखादं वियर्ड डिव्हाइसच असणार आहे. जसं की एक आपली सीव आहे, ती सीव आपण अशा प्रॉपर सीव काय करायची, एखाद्या अशा डिव्हाइसला फिट करायची की त्या डिव्हाइसला खालच्या साईडला व्हील्स असतील. ओके, आणि अशा डिव्हाइसवरती फिक्स केल्यानंतर ते व्हील्स काय होतील, ते व्हील्स रोटेट होतील फ्रॉम वन प्लेस टू अनादर प्लेस, आणि मूवमेंट होणार आहे. ते व्हील्स मूव काय करतील, सीवला एका प्लेसवरून दुसऱ्या प्लेसवरती घेऊन जातील विथ द मटेरियल. ओके, मटेरियल लोड केल्यानंतर काय होईल, ते जे काही सीव आहे ती rotate wheel from one place to another place, and which gives the proper size reduction. Okay, and this gyration also most commonly used for the size reduction purpose. Then this is all about the types of this is all about the agitation. Okay, agitation possesses 3 points: oscillation, vibration, and gyration. And these agitation methods are not continuous method. Okay, and these can be made continuous by inclination of the sieves, and also it is used for the particularly rotax screen. It is used in the rotax screen. Also normally all 3 modes of agitation are used simultaneously for and efficient size separation. ओके, सायमल्टेनियसली तिन्ही पण ऑपरेशन एखाद्या मटेरियलवरती केले जातील. फर्स्टली काय होईल तर ऑसिलेशन, त्याच्यानंतर ऑसिलेशनमधून जर एखादं मटेरियल प्रॉपर पास झालं नाही तर तेच परत व्हायब्रेशन टेक्निकमधून पास केलं जाईल, आणि लास्टला कुठल्याच टेक्निकमधून पास केलं जाईल तर गायरेशन टेक्निकमधून, आणि आफ्टर गायरेशन इट गिव्स द प्रॉपर साईज सेपरेशन. Then this agitation have the advantages, that is it is an inexpensive technique, and also it is very simple and rapid technique. But the disadvantage is that these agitation methods have lower limit of particle size. Okay, it have lower limit of particle size. Also, second disadvantage is that if the powder is not dried, okay, it is not dried means it possesses a lots of moisture, then the aperture becomes clogged with the particles leading to improper sieving. म्हणजे काय तर एखाद्या मटेरियलमध्ये, एखादं पावडर मटेरियल आहे त्याच्यामध्ये जर लॉट्स ऑफ मॉइश्चर प्रेझेंट असेल तर ते मटेरियल सीवमधून प्रॉपर पास होणार नाही, अँड इट गिव्स द म्हणजे जे काही सीवचे ओपनिंग असतील ते ओपनिंग क्लॉग होईल आणि प्रॉपर साईज सेपरेशन होणार नाही. Then third disadvantage is that during agitation, okay, during agitation attrition is occur, so it causes a size reduction. Means आता एखाद्या प्रिपरेशन मध्ये आपल्याला कोर्स पावडर पाहिजेत, ओके, कोर्स पावडर पाहिजे तर ते कोर्स पावडर आपण फक्त सीव मधून एकदा पास करणार आहे, ओके, आणि कोर्स पावडरची रिक्वायरमेंट आहे. म्हणजे आपण काय करणार, साईज रिडक्शन करणार एखाद्या मिल थ्रू, आणि आपल्याला रिक्वायर्ड काय आहे तर कोर्स पार्टिकल रिक्वायर्ड आहेत. मग आपण ते मटेरियल एकतर मोठे मोठे पार्टिकल ठेवलेले आहेत पण त्याच्यामधून पण आपल्याला सीवमधून पास करून कोर्स मटेरियल पाहिजे. तर अशा कंडिशनमध्ये जर आपण सिविंग करतोय म्हणजे ह्या एजिटेशन मेथड थ्रू, म्हणजे एकतर गायरेशन असेल किंवा व्हायब्रेशन असेल, गायरेशन असेल, व्हायब्रेशन असेल किंवा ऑसिलेशन असेल, या टेक्निक थ्रू आपण काय करणार आहेत, सिविंग करणार आहेत. मग ते करत असताना एकतर ऑसिलेशनमध्ये पण काय होते, स्विंग लाईक स्ट्रक्चर, ओके, स्विंग लाईक मुवमेंट होते. व्हायब्रेशनमध्ये पण काय होते, व्हायब्रेशन ऑकर होते सीवला, आणि सीव काय करते, प्रॉपर साईज रिडक्शन करते. आणि गायरेशनमध्ये तर काय होते, व्हील्सच रोटेट होत आहेत फ्रॉम वन प्लेस टू अनदर प्लेस. मग हे तिन्ही पण मेथड आपण सायमल्टेनियसली यूज करतोय फॉर द इफेक्टिव्ह साईज रिडक्शन. मग हे होत असताना काय होतंय, जर आपल्याला कोर्स पार्टिकल्स पाहिजे असतील तर आपण ह्या पास करत असताना इथं तिन्ही मेथडमधून काय होणार आहे, मटेरियलचं ॲट्रिशन होईल. म्हणजे ते पार्टिकल्स काय होतील, कोलाइड्स होतील. दिस पार्टिकल्स बिकम्स कोलाइड्स विथ इच अदर अँड इट गिव्स द ॲट्रिशन अँड इट गिव्स द size reduction. Okay, again size reduction, it gives attrition, means it gives a again size reduction. It is fully wastage of material because we required coarse particles and these coarse particles becomes very fine particles, then it is full of wastage of material. This is the disadvantage of the agitation method. Then third method or third modes of size separation, it is ब्रशिंग मेथड. इन ब्रशिंग मेथड इथं काय आहे तर सिंपल एक प्रकारचा ब्रश असणार आहे, ओके, एक प्रकारचा ब्रश जो की सीववरती अशा प्रकारे सेट केला जाईल सेंटरला, जी की सिविंग होत असताना सायमल्टेनियसली तो ब्रश काय होईल, रोटेट होईल. ओके, मिडलला आपण काय करणार आहेत, तो सर्क्युलर सीववरती असा प्लेस करणार आहेत की तो लॉन्जिट्युडनल ॲक्सिस इन केस ऑफ हॉरिझॉन्टल सिलेंड्रिकल सीव, याच्यामध्ये आपण काय करणार आहेत तर असा प्लेस करणार आहेत की तो सिविंग होत असतानाच तो ब्रश रोटेट होईल त्या मटेरियलवरती आणि प्रॉपर साईज म्हणजे प्रॉपर साईज सेपरेशन होईल. म्हणजे काय तर ऑसिलेशन करत असताना आपण पाहिले की ऑसिलेशन होत असताना फक्त मटेरियल रोटेट होते सरफेसवरती. अशा कंडिशनमध्ये जर ब्रश आपण अप्लाय केला तर ब्रश काय करेल, प्रॉपर पार्टिकल्सची मुवमेंट करेल फ्रॉम वन प्लेस टू अनदर प्लेस आणि प्रॉपर साईज सेपरेशन होईल. तसंच फॉर एक्झाम्पल हा ब्रश कशासाठी यूज केला जाईल तर साईज सेपरेशन ऑफ ग्रीसी और स्टिकी पावडर्स सच एज वॅक्सेस अँड सोप्स, अशा प्रकारचं मटेरियल ज्यावेळेस आपण सीवमधून पास करणार आहेत तर त्यावेळेस काय होणार आहे, एकतर जे काही सीवचे होल्स असतील ते क्लॉग होण्याचे चान्सेस असतात स्टिकी ग्रीसी मटेरियलमध्ये. तर जर ब्रश त्याच्यावरती रोटेट होत असेल सायमल्टेनियसली सिविंगचे प्रोसेस होत असताना, तेव्हा ते मटेरियल काय होईल, ते जे काही क्लॉगड पोर्स असतील, होल्स असतील ते रिमूव्ह करेल आणि प्रॉपर साईज सेपरेशन होईल. देन नेक्स्ट मेथड इज सेंट्रिफ्युगल मेथड. इन दॅट a high speed rotor is fixed inside a vertical sieve so that the rotation of the particles are thrown towards by centrifugal force. In this method, centrifugal force arises and it gives the proper size separation. The current of air created by the movement helps sieving and also especially is useful with very fine powders. Here the current of air can be generated, okay, by means of jet of air into equipment which helps in separating the particles. Example is cyclone separator and air separator. हे दोन्ही इक्विपमेंट आपण नेक्स्ट लेक्चर मध्ये डिटेल मध्ये डिस्कस करणार आहेत विथ प्रिन्सिपल कन्स्ट्रक्शन अँड वर्किंग. अँड दिस सेंट्रिफ्युगल मेथड हॅव advantages. Two advantages is there, such as first is this method is extremely useful in case where conventional sieving tends to block the sieves. म्हणजे काय होईल तर अशा प्रकारच्या मटेरियलमध्ये यूज केलं जाईल की ते मटेरियल सिवला अगेन अँड अगेन ब्लॉक करते. मग जर इन केस जे मटेरियल सिवला अगेन अँड अगेन ब्लॉक करते अशा मटेरियलसाठी सेंट्रिफ्युगल मेथड यूज केली जाईल. म्हणजे ब्रशिंग आणि ॲजिटेशन मेथड अवॉइड करून सेंट्रिफ्युगल मेथड यूज केली जाईल. ऑल्सो इट इज extremely useful for fine powder because sieves have the limitation of mesh size. Okay, sieve have the limitation of mesh size, so we use the centrifugal method for the proper size separation. Then this is all about the centrifugal method. Okay, then next is the equipments. What equipments used for the size separation? There are four equipments are used for the proper size separation. First is the sieve shaker machine. Second one is the cyclone separator. Third one is the air separator, and fourth one is the bag filter. These four types of equipments are used for the proper size separation. We discuss these equipments one by one. Okay, here first one is the sieve shaker machine. Sieve shaker machine, here it is looks like this. Okay, this is an equipment used in the laboratory as well as industrial purpose. Here this is the sieve shaker machine. In that principle याच्यामध्ये काय असेल तर it is work on the agitation. Okay, in that agitation मध्ये कुठला असेल तर vibration. So this agitation gives the proper size separation. Then what is the construction in that this machine consists of here first one is this is a button used for on off the machine. Then here the timer, this is the indicator bulb here. Okay, here this is a receiving pan after the proper size separation. Here the sieves are arranged in such a way that it is arranged in a ascending order, means very finest sieve सगळ्यात खालच्या साईडला ठेवली जाईल आणि त्याच्यानंतर मग अगेन अँड अगेन वरच्या साईडला. इथं सगळ्यात वरती कुठली असेल तर कोर्स सिव असेल, म्हणजे सगळ्यात मोठी सिव, त्याच्यामधून पटकन मटेरियल पास होईल. ते मटेरियल अगेन खालच्या सिवमध्ये येईल, अगेन खालच्या सिवमध्ये, असं करत करत ही मटेरियल कुठे येईल तर ह्या रिसिव्हिंग पॅनमध्ये येईल. ओके, इट इज अरेंज्ड इन सच अ वे दॅट इट इज ascending order. This is a sieve set. Okay, here one lead is placed. Okay, after the material load केल्यानंतर हे lead place केलं जाईल for the sterility maintain purpose. Okay, this is the construction. Then in the working, okay, here sieves are arranged in a nest with the coarse at the top. A sample 50 gram of powder is placed on the top sieve. This sieve set is fixed to the mechanical shaker apparatus and shaken for a certain period of time, that is 20 minutes. The powder retained on each sieve is weighed. Okay, here in this आपण काय करणार आहेत here okay, इथं सिव कशा सेट करणार आहेत तर कोर्स जी काही सिव असेल ती वरच्या साईडला असेल आणि इथं काय असेल सगळ्यात खाली फाईन सिव असेल. ओके, फायनेस्ट सिव असेल तर याच्यामध्ये काय करणार आहेत, मटेरियल आपण लोड करणार आहे. अप टू 50 ग्रॅम ऑफ पावडर लोड करणार आहेत. ओके, लोड केल्यानंतर लीड प्लेस करणार आहेत. लीड प्लेस केल्यानंतर हे प्लग स्टार्ट करणार आहेत. प्लग स्टार्ट केल्यानंतर मेकॅनिकल शेकर, इट इज वर्क्स लाईक अ मेकॅनिकल शेकर. हे मेकॅनिकल शेकर आहे. हे काय करेल, ह्या ज्या काही सीव आहेत त्यांना शेक करेल, आणि शेक केल्यानंतर किती टाईम पिरियड, किती टाईमापर्यंत शेक करायचे, तर अप टू 20 मिनिट. ओके, 20 मिनिट शेक केल्यानंतर, ओके, आफ्टर शेकिंग we stop this device, then we remove the powder. Okay, here powder, it is receiving pan, comes in the receiving pan. आणि जे काही सीव आहेत त्या सीवच्या वरच्या साईडला जी काही डिस्कार्ड होईल पावडर, म्हणजे जी काही रिटेन राहील पावडर वरच्या साईडला, ती पावडर काढून म्हणजे रिमूव्ह करून ती त्याचं वेट घेतलं जाईल. ओके, हे जे काही आहे डिवाइस, हे आपल्याला प्रॅक्टिकलमध्ये आहे. प्रॉपर आपण काय करणार आहे, प्रॅक्टिकलमध्ये काय करणार आहेत, प्रॉपर आपण हे सीवचा सेट तयार करणार आहेत. सेट करून याच्यावरती मटेरियल 50 ग्रॅम लोड करणार आहेत, आणि त्याच्यानंतर प्रॉपर व्हायब्रेशन देणार आहे त्या मशीनला. आणि मशीन काय करेल, प्रॉपर व्हायब्रेशन प्रोव्हाइड करेल या सीवला, आणि प्रॉपर साईज सेपरेशन होईल. पण आफ्टर साईज सेपरेशन थोडंफार मटेरियल या सीवच्या वरती राहणार आहे, प्रत्येक सीवच्या वरती ते आपण रिमूव्ह करणार आहेत, आणि त्याचं वेट घेणार आहेत. म्हणजे बिफोर अँड आफ्टर वेट it is taken in this machine. Okay, then this machine have the advantages and disadvantages. What are the advantages? It is inexpensive, it is simple and rapid with reproducible result. And what are the disadvantages? There are 3 types of disadvantages, such as it have the lower limit of particles, that is 50 micrometer. Means this machine gives only 50 micrometer size particles. Then next disadvantage is, if powder is not dry, then aperture get clogged with the particles, leading to improper sieving. इथं काय होईल, तर एखाद्या पावडरमध्ये लॉट्स ऑफ मॉइश्चर प्रेझेंट असेल, तर काय करेल, ह्या सीवचं जे काय अपर्चर आहे, जे काय ओपनिंग असेल, ते ओपनिंग काय होईल, इट बिकम्स क्लॉग्ड, अँड प्रॉपर साईज सेपरेशन होणार नाही, कारण इथं एखादा ब्रश पण प्रोव्हाइड केलेला नाही to remove this the clogged particles. Okay, then third is the during shaking attrition. Okay, obviously attrition is occur, and it gives the size reduction of particles, which is not good for if we require the coarse powders. Okay, means here attrition is occurs, and these particles collides with each other, and it gives the size reduction of the particle. This is the disadvantage of the sieve shaker machine. This is all about the sieve shaker machine. याच्यामध्ये simple, it's looks so complicated, but it is not like that. It is very easy. In that only we have to take the set of this sieve and arrange in a ascending order. Okay, ascending order मध्ये सेट करायचे. फक्त सेट केल्यानंतर काय करायचे, ह्या वरच्या साईडला, इथं वरच्या साईडला मटेरियल प्लेस करायचे. अप टू 50 ग्रॅम ऑफ मटेरियल प्लेस केल्यानंतर लीड प्लेस करायचे वरच्या साईडला. लीड प्लेस केल्यानंतर प्लग स्टार्ट करायचं इथून. ओके, प्लग स्टार्ट केल्यानंतर इथं टायमर पण सेट होईल. इथून मशीन ऑन करायची. ऑन केल्यानंतर काय होईल, दिस डिवाइस गिव्स द व्हायब्रेशन टुवर्ड्स दिस सीव काय करेल, ॲजिटेशन ऑपरेशन थ्रू ऑपरेट होईल. ॲजिटेशनमध्ये व्हायब्रेशन प्रोव्हाइड होईल. व्हायब्रेशन प्रोव्हाइड झाल्यानंतर जे काही मटेरियल असेल ते 1 बाय 1 ह्या सीवमधून पास होईल, आणि ह्या रिसिविंग पॅनमध्ये येईल. ओके, दिस इज ऑल अबाउट द सीव शेकर मशीन. देन नेक्स्ट वन इज द सायक्लॉन सेपरेटर.